So part 284, C3M1B7C8E13C9C6D3p38d19d7b14. Line 22f1fa19c3m1b7c8E13c9c6D3p38d19d7b14. Water vapor plasma glass surfaces 5G Wow Seti. There's the alien radio signal, and this data was worked on March the 15th, 2013. Today's May the 11th. Oh, okay, warning. This is a long video. I had to keep all the data together. It's for water, vapor, plasma, glass, all in PDF files of results to use with a long-distance signal device found on Wildcat. So these PDF results are from experiments that you have done, scientists and physics and chemistry people have done, and I've collaborated and put them all together because they came up with the keywords. Okay, so this should be interesting. So Ti-sapphire laser, thin film beam splitters, then we have passive optical network, then we went to radio frequency over glass. This line of data, RFOG steam vapor signals was our last video. So then I put these words together: radio frequency glass steam vapor and water vapor plasma treatment of glass surfaces. Quote PDFs from blogs. Water vapor plasma treatment of glass surfaces. Abstract. The density of hydroxyl groups present on the surface of glass, such as e-glass fibers, is increased by subjecting the surface to a radio frequency induced glass plasma containing water vapor. Surfaces so treated exhibit enhanced absorption of hydrolyzed organosilane coupling agents applied to improve adhesion between glass fibers and resin matrices in the manufacture of reinforced composites. That's from 1998 to 2001. There's the inventors, Shawn and Dougal, and there's probably two more, it says. ExxonMobil. Description: OCR text may contain errors. Water vapor plasma treatment of glass surfaces. Field of the invention. The present invention relates to a process for increasing the number density of hydroxyl groups present on glass surfaces by subjecting such surfaces to a water vapor plasma treatment. Now, I found this so interesting, I actually got all the notes from this. It's usually with the PDF files, I only do just the abstract. But this was so interesting, I wanted to look at their notes and see what it is, because I don't know what this is, and I'm just trying to figure it out from the notes. Okay, so background of the invention. Okay, fiberglass reinforced resinous composites and laminates are well-known materials used in many applications, including oil field piping as well as automotive, marine, and building applications. Articles are generally prepared by embedding continuous or chopped fiberglass filaments or bundles in a curable resinous binder, such as a polyester or epoxy resin, followed by shaping and curing the shaped structure. The fiberglass serves to reinforce the structure, giving rise to articles having improved strength and stress and shear resistance. So I'm assuming they will use those for places that are tornado prone or earthquake prone. In order to maximize mechanical properties as well as chemical resistance of the structure, it is necessary that a strong bond be developed between the resin matrix and the fiberglass reinforcement surfaces at their interface. The development of this strong bond may be achieved by coating the fiberglass with a hydrolyzed organofunctional silane coupling agent having the general formula of X3SI, where an X is a hydrolyzable halogen or alkoxy group, and R is an organic radical having functionality which is either capable of reacting with the curable matrix resin or at least highly compatible with the matrix resin. The hydrolyzed silane is initially absorbed onto the surface of the glass and forms hydrogen bonds. There's a keyword there, hydrogen bonds. We always talk about that, right? With 3 hydroxyl groups normally present on the glass surface. Subsequent heating of the coated glass surface converts these bonds to covalent siloxane bonds in accordance with the following reaction schematic. So this is a deposition of silane. There's the formula there. The glass formula. According to its evident that the quantity of hydrolyzed silane which can be absorbed, I don't know if it's supposed to be absorbed or sorbed, whatever, onto and bonded to the glass surface is a function of the number density of hydroxyl groups available on the glass surface with which the hydrolyzed silane can hydrogen bond. The present invention provides a method for increasing the number density of hydroxyl groups on glass surfaces by subjecting such surfaces to a water vapor plasma treatment. We're almost halfway. It is known in the prior art to subject various substrates to a plasma gas treatment to alter the surface characteristics of the substrate. For example, B. Das disclosed in sample 1992, pages 33 to 39, the cold plasma treatment of pre-sized glass fiber bundles in the presence of an activated gas such as argon. See, there's another keyword. We have argon gas and we have fiber optics going together, plus we have glass. So this could be used for something major. Oxygen, ammonia, freon, or a mixture of oxygen and freon. The authors note that some sort of surface modification of the size fiber surface is achieved as evidenced by differences in water wettability of the treated fiber versus the untreated fiber. I wonder if they make their surfaces as lattices or not. That'd be interesting. I'm getting all these little ideas as I go along. Similarly, V. Krishnamurti al. disclosed in Journal of Math Science 24, 1989 at pages 3345 to 3352. The argon gas plus treatment of glass fibers to etch their surface and increase the surface wettability, followed by plasma polymerization onto the treated surface of selected monomers. There's monomers again. We had monomers with magnets coming up before. Designed to enhance the adhesion of the treated fibers to polymer matrices. U.S. patent 4,675,205 discloses the surface treatment of a material such as an epoxy fiberglass composite by subjecting it to a hot gaseous plasma, which also may contain a reactive gas such as water vapor or BC1. The treatment is disclosed to enhance the adhesion of ceramic material subsequently coated on the plasma-treated surfaces. However, none of these references disclose exposure of clean glass or fiberglass surfaces to a water vapor containing plasma and the resulting generation of an increased number density of hydroxyl groups on such surfaces. It is also known in the art of subject various substrates to glow discharge plasma in order to clean or sterilize such surfaces. Such cleaning is required to prepare strongly adhering films via vacuum evaporation. It's commonly used in the coating and electronics industry. Glow discharge is also used in the medical field for, I never heard of it before, the cleaning and sterilization of microscope slides and surgical instruments. Summary of the invention. The present invention provides a process for increasing the number of hydroxyl groups on a clean glass surface, comprising contacting said surface with a radiofrequency-induced gas plasma containing water vapor. Brief description of the drawings. Figure 1 depicts the sum frequency generation SFG spectra showing the hydroxyl group density of a glass surface before and after the plasma treatment of this invention. For some reason there was no pictures with this. I apologize. Figure 2 depicts the SFG spectra showing the absorbed hydrolyzed saline concentration on a glass surface before and after the plasma treatment of this invention. Figure 3 depicts the X-ray photoemission O spectra of a glass water with different surface treatments. Detailed description of the invention. Plasma gas may be generated by radiofrequency RF ionization of gas molecules, usually in a reduced pressure chamber. Initiation of discharge within the chamber develops a plasma gas, which comprises a mix of positively and negatively charged particles arranged in such a way as to shield externally and internally generated electrostatic fields. Within these regions, activating gases or vapors display a wide variety of chemical properties which differ from those encountered under normal conditions. Particle separation within the plasma creates a potential which becomes the primary source of surface activation, causing ionic and free radical surface reactions. Water molecules present in the RF plasma or the plasma glow region become highly excited, ionized, and dissociated. In accordance with this invention, a method is provided for increasing the density of hydroxyl groups present on the surface of clean glass. By the term clean glass is meant glass which is free of any pre-applied surface coatings such as glass sizing, coupling agents, or adhesive agents. Suitable glass includes silica, alumina, silicate, and other oxide glasses. Most preferable glass is E-glass, which contains about 55% WTSiO2, that's with a little 2, as the main component, with the remainder being oxides of other elements such as Al, Ca, B, and C. The glass may be in the shape of fibers, films, or wafers, or may be particular glass which is used as filler or a catalytic substrate in a number of applications. So I wonder if they ever used it with obsidian glass, because it doesn't say that, but I wonder if you did use it with obsidian glass, what would happen. The invention is particularly applicable to continuous drawn fiberglass fibers bundles, which are used as reinforcing fibers in the manufacture of polymer-bound composites. We're almost done. We're 3/4 of the way. The glass surface treatment can be carried out by subjecting the glass surface to an RF-induced glass plasma containing water vapor under conditions such that the water molecules become highly excited, ionized, and dissociated. That looks familiar. In this condition, the water quickly hydrates the glass surface, which it contacts, leading to increased hydroxyl group density on the glass surface. The process may be conducted at ambient temperatures by passing the continuous glass fibers through a plasma torch or glow discharge, which also contains added water. The water may be sprayed into the discharge in the form of a liquid or steam, and may be applied to the glass surface prior to entry of the glass into the discharge. The process may be conducted in the atmosphere in the presence of ordinary air, or may be conducted in a reaction chamber in the presence of air or other gases such as nitrogen, helium, or argon. Preferably the air surrounding the glass surfaces is at least 30% saturated, more preferably at least 50% saturated, with water vapor during the plasma treatment. The process may be carried out at temperatures in the range of about 20 degrees Celsius to 100 degrees Celsius, but is preferably carried out at ambient temperature about 25 degrees Celsius. On a laboratory scale, the process is best illustrated using an inductively coupled plasma reactor such as Bronson IPC 3000 or a Herrick Scientific Corporation PDC 32G, operating at a frequency of 13 to 14 megahertz and a power level of from about 50 to 150 watts. The glass sample to be treated is placed in the reaction chamber, also referred to as the vacuum envelope, which also contains a source of water vapor. The water vapor source may be simply water drops or a container of water placed in the chamber of water in the form of ice. Alternatively, the chamber may be equipped with a water inlet valve, which permits the introduction of a water vapor or steam spray from outside the chamber. The reaction chamber is then evacuated using a vacuum pump down to a pressure of about 0.01 to 0.05 torr. Once the equilibrium partial pressure of water in the chamber at ambient temperature is reached, the glass sample is exposed to the low pressure RF of the plasma generator for a period of time ranging from about 30 seconds up to 15 minutes, depending on the nature of the size of the glass sample. The process may be carried out in the presence of air and/or one more relatively inert gases such as argon, nitrogen, or helium. Reactive gases such as chlorofluorocarbon or ammonia should be avoided, as these may lead to the generation of unwanted reactive species on the glass surface. As indicated above, the density of the hydroxyl groups on the surface of glass exposed to the water vapor plasma treatment of the invention is increased as compared with the untreated glass or glass plasma treated in the absence of added water. This density increases in hydroxyl groups means that glass will absorb more of the hydrolyzed coupling agents, which initially from hydrogen bonds with the hydroxyl groups present on glass surface when applied to such surface. We're almost done. Typical of such coupling agents prior to hydrolysis include methyl trichlorosilane, methyl trimethoxysilane, vinyl trithoxysilane, gamma amino. Where do you guys come up with these words? Propyl triethoxysilane and other mono or polyfunctional alkoxysilanes are well known in the art. And that's a google.com patents link. So April 21st, 2013. So I Google more keyword ideas. Radio frequency glass steam vapor plus water vapor plasma treatment of glass surfaces plus X-ray photo emission OLS spectra. Just so you know, there's going to be at least 15 videos with this keyword here. I know, because I've got like a whole list to write down and film. I got I'm ready to film, but I write down the titles and I keep track with check marks so I know which one I've done. There's no way to ever remember it all. So the source of the keyword was a Google pen, and the keyword in the next video isn't listed. And let's see what it is. I think it's the X-ray. Yeah. We're looking at the X-ray photo emission OLS spectra over the next 15 videos or so, because a lot of stuff came up with it. Okay, thanks for watching for the last 15.5 minutes.